You all can hear me, right?
Yes.
So I have taken this restaurant reviews data set and I'm going to do some sentiment analysis. Sentiment analysis is classification problem. I already explained. So I am going to represent this text into numbers and then I am going to build a machine learning model. To represent this text into a numbers, we need to do some process, NLP, natural language processing. So what are those steps? First we'll know, right? There'll be, things like removing stop words, right? Stop words are the words which are not that important in deciding whether a review is positive or not, right? In this particular sentence, loud is the positive word, right? Good is the positive word. Crust is actually the subject and good is actually trying to describe that, right? And then nasty is another important word. But just, was, the, and, right? These all words are there, but they may not actually talk, tell anything about the positivity or negativity of the sentence. So those kinds of words which are not important in deciding the target variable are called as stop words. Okay. Each word is a feature. Each word is a column in our data set. Okay. When you talk about representing data in the numerical format and bag of words, we are taking each word as a column and how many times the word occurred is going to be the numerical representation. That is bag of words, right? You remember that, right? Bag of words, you remember? Any questions there?
It's clear, sir.
Right? So, we collect all the distinct words from the total data and represent those words as the columns and take the first document, then, count how many times that word occurred. The matrix is going to be sparse and then likely is going to be y value and we'll put y values and then build a model. You can build a logistic regression. You can build a, naive Bayes or any algorithm you can build, right? Any classification algorithm you can build. That is called a sentiment analysis on text. And we need to remove the stop words to reduce number of columns. Right? If you take all these words, right, there'll be too many words in the data set. That is one problem. The second problem is these stop words, is, was, and, the, right? These words will occur many times in the data, and in those particular columns, right? For the column, for was column there will be high count. For is column there will be high count. For the column there will be high count. Instead of having the high counts for these important words like good, nasty, right, texture, these kinds of good, important words giving high priority, the model will give high priority to is, was, and all those stop words. So the essence may not be captured properly. Two problems. One, too many features. If you keep stop words, too many features. Second, the importance may not get focused on the words which are deciding the sentiment, right? So removing stop words is good when you are doing classification tasks like sentiment analysis. But if you are trying to do grammatical check, right, stop words are also needed. So depending on the problem we are trying to solve, we should be removing stop words or keeping them, and the list of stop words will also change. Depending on the problem we are trying to solve, the list of stop words will also change. Okay, so stop words we need to remove, then tokenize it. What is tokenization? There are many sentences in the data set. You need to take distinct words from these sentences, right? So you need to take distinct words. That is called as tokenization. You will take distinct words from total data, not individual sentences, right? Total data, distinct words. There may be, place occurred maybe 10 times in the total data, but you will take only once. Okay. So you tokenize individual sentences and, try to consolidate it as distinct words. Right? This whole process is called as tokenization. We do tokenization on individual sentences and then consolidate into individual words. Okay, so this is the input: friends, Romans, countrymen, you know, lend me your ears, right? This is a sentence. The output is going to be like this, commas, with commas. So for tokenization, right, there are different techniques. We'll see them tomorrow, right? We can use regular expressions to tokenize. We can use space as the delimiter to tokenize. Right? Here, the space is used as delimiter. That's where, and punctuations were removed. Space was taken as to delimiter, and punctuations were removed. That's where you got individual words as the tokens. Okay, then stemming and lemmatization. So this is all curation process. Okay, you remove stop words, tokenize the text, then you do stemming or lemmatization. What is stemming? In a corpus there may be you know um, there may be sentences like there may be words like stopped, stop, stopping, right? There may be three words: stop, stopping, and stop. So out of these three words, right, all are actually trying to say something is stopped, right? Something was stopped or is stopped, right? So you can take the root word instead of taking all three words as distinct words. You can take one word, the root word. That way you reduce the number of columns. One thing, the intensity of the column will increase, right? If stop, the present tense, past tense, and the future tense of the stop occurred in maybe out of 1,000 documents, maybe in 100 documents, right? If there are three different forms of it, then in the ultimate data set, right, you will get three different columns, right? Stop, stopped, and stopping, right? And maybe out of those 100, 10 belongs to stop, maybe 20 belongs to stopping, maybe remaining 70 belongs to stopped. So that way, right, you will actually get the counts distributed among three columns. If you take all three variants, all three present tense, past tense, and future tense of a word, and try to create features in the data may get distracted, or data may get diluted. If you try to take all as one word, stop, then that column actually gets a higher number. Do you agree? Are you understanding what I'm actually talking about?
Yes, sir. Yes, sir.
Yes, sir.
So we will actually try to choose that root word. Choosing that root word, right? Stop is the root word. Stopping and stopped are the derivatives of the root word, right? So choosing that root word can be done in two ways: stemming and lemmatization. What is stemming? Stemming actually tries to take. It will have rules, right? STO, PPED, stopped, right? So it will actually take out ED only. Okay, it will take ed, right? If there is ing form, it will take ing, right? Like that. Okay, stemming will have some rules for every language, right? If the tool is supporting, now we are going to use NLTK, but NLTK is not used in production. SpaCy, Flare, Stanza, these kinds of modules are used in production. So I'll show those also, right? In NLTK there may be some support for languages, but these other modules, right? They have the other libraries. They have support for other languages. So when they support a language like English, there will be some rules, stemming rules. Based on those rules, it will actually stop off. If chop off. If you do stemming for stopped, it will actually remove ed and it will take stopp, or maybe see, it actually took stop only. TED it removed. So there is a rule, if stopped comes, remove it like that. It's a rule based one. It's a brutal, it's a brute force they call it as. Right? It's a dumb way of finding out the root word. Sometimes what happens is, for the same word, there may be two distinct words we may find. Because of the rule based chopping, you may find two different words. That is one problem with stemming. The second problem is uh, there is a swan and swing, right? Two words. Suppose that there are two words, swan, S-W-A-N, and there is another word called as swing, S-W-I-N-G. If lemmatization rule is in such a way that an should be removed, if it is if the an occurs in the end of the word, remove it, and ing form occurs at the end of the word, remove it, then swan and swing both will be represented as SW. After tokenization and stemming, right, you will have SW representing swan, SW representing swing. So these are the two problems with the stemming, right? Is there any issue if I represent SW, swan as SW and swing as SW? Is there any problem?
Yes, those are two different words, right?
Two different words. If I represent them with two same word, what will happen?
It will represent it both as a single word, and it
Ah,
gives high weightage.
it will actually give unnecessary weightage, and the data represented, original data's essence is being lost, right? So, original data's essence is lost, right? Do you agree with my statement?
Yes, sir.
Give me 1 second. I'm trying to find my pen. Give me 1 second. Give me 1 second, okay? I'll get the pen. So you are getting it, but I, out of my finicky nature, right? I would like to show that. Okay. So the way we are trying to convert this data is, see this. These are all the distinct words we found after after the tokenization and stemming. Okay. So once we find these words, right, distinct words, the data set is formed like this. Wow. Taste, crust, good, like that. Okay. And I have a question here, right? So that's where I'm actually trying to write. So this is x1, this is x2, this is x3, and so on, xn, right? So One thing is that in text data, you will get high dimensional data sets, right? High dimensional data sets. Dimensionality reduction is one of the PCA and all those techniques we already learned, right? Some techniques, right? The first row is going to be 1, 1, 1, 0, 0, 0, and so on 0. Right? The second row, second word, second document, the crust is going to be 1 like that, right? So there may be repetition of words, right? So maybe place occurred in some other word, some other sentence, you will get 1 here, or maybe 2 here, something like that. So if I represent swan and swing as one word, right? One word, swan and swing, right? Swan and swing, right? If stemming technique is chopping this off and chopping this off, we are representing. They are two distinct words. If we want to extract the syntactic, essence of the data, we should have two different features in it, right? Swing is one different word and span is other different word. There should be x4, x5, two different features, but we are combining these two and creating one feature. So this is actually wrong representation. It is actually corrupting our data. The essence of the data is not being carried forwarded to the numeric representation, right? That's a danger. That's a danger with stemming. This will not happen. Very rare. It is very rare that it happens. Okay, but I am trying to exaggerate and show the problem here. Okay, so there was another point I tried to. I'll ask question in a moment. Right, I have one question here, but I have to cover a little more thing. I forgot another point. Yeah, the the other point I was trying to explain is, uh, like, liked, and liking, right? These three are three distinct words. If stemming actually takes the root word like, then what happens? You will get one feature like, and you will have high scores here, right? And maybe 2, maybe 1, maybe high scores here. This will actually will have more impact on the target variable. Instead of creating one feature, if you create three features, like, liked, and liking, three features, then the essence of that column or the feature or the word is going to be spread across three columns, and the strength of that feature, right, in deciding target variable may reduce. Or why am I saying may reduce? Because there are other noisy features, right? There are other noisy features which may have zeros in there, or maybe other number. Noisy feature I said because for some reason, if you haven't, removed some of the word which is not that important, maybe this dam is not that important, you haven't removed it, and there is a count for it, that's noisy feature, so they are actually going to be distractive. So if you create important features by doing stemming or lemmatization and consolidate, or create a concentrated features which are important, then it will override the noisy features impact. Okay, that's the whole process. In this NLP, that natural language processing steps, we call these as normalization, text normalization, we call these as part of text normalization, we are actually applying these. Okay, and stemming is one technique. Lemmatization is more scientific in nature. Scientific in nature, I say, because it actually looks into a corpus called as WordNet. Corpus is like a set of documents which are labeled already. Labeled, I'll talk about labeling, maybe tomorrow, or day after tomorrow. So it is like looking at dictionary and trying to decide whether the word is, proper or not, or looking at some mapping and trying to, find out the root word. That is lemmatization. Okay, looking at some source and then deciding the root word is lemmatization. This is more appropriate, but it takes more time because it need to look into each and every words mapping and then decide, whether the root word is correct or not, right? So stemming is fast, but it may cause, damage, like, see, berries are being, you know chopped as berri, berry, right? Apples, down to appl, right? Like that. But one point we need to remember is whether you do stemming or lemmatization, the resultant words, if they have meaning or not, it doesn't matter. Only point we need to remember is they should not overlap, right, or collapse multiple features into one feature like swing and swan. Are you getting it? Whether you apply stemming, lemmatization, or your own technique to find out root word, the technique should not mix distinct words into one word or should not map distinct words into one word. Got it? After stemming lemmatization, the resultant sentence's meaning doesn't matter. See this here? Is this syntactically correct? Whatever I am highlighting, tasty, texture, nasty. Spellings correct? Are those spellings correct? Here also. Right? After processing, whether spellings correct or not, grammatically correct or not, doesn't matter. Only thing you need to remember, only thing we need to focus on is whether the words are not overlapped or not. Okay, got it? Any questions on the statement I made? Any questions?
No, sir.
Why the meaning is not important?
See, we only care about the influence of a particular word
Yes,
on the final result, but
yes,
not the meaning.
yes, sir. Good, sir. Right. We are actually creating a numerical representation there, and the numerical representation is going to form an equation, right, with numbers, right? So it doesn't matter. The meaning ultimately, anyway, you are going to use numbers only. You are not going to use words. But the only thing we are trying to do while doing NLP is that we are trying to consolidate or we are trying to intensify the features importance by reducing number of forms of the word and all that. Okay, that's good. You got it, right? So that is the natural language processing, at a high level. This is the beginning of natural language processing. This part is called as text normalization. Right? Generally, what we do is we take the text and try to uh, bring it down to lowercase, because sometimes the same word will be present in lowercase, uppercase, or first letter upper. We call it as typecase. I think first letter upper and rest all lower, or maybe sometimes we will have in between uppercase letters. Right. So you bring it down to lowercase and then try to do the text normalization. Okay. So I have taken this data set. I looked into the data set. Then I am actually downloading this NLTK. First time when you download, first time when you actually say import, right, it will say it is not available. You need to download it. NLTK.download stop words you need to download. Or you can download, you say download, it will download all corpuses and everything. Okay. So in NLTK corpus, there are stop words, right? Already predefined stop words. I said that depending on the problem you are trying to solve, the stop word list will change, right? Is a stop word, not is not a stop word. But you need to be careful. If you remove not, right, the good and not good, no, you will get from this you will get good as a feature, and from other feature also you will get good as the positive one also you get good. The model will get confused. Once it is zero, another place it is one, right? So not is not a stop word, so it should not remove. It will not, but I'm just trying to exaggerate things and show, right? So here, like the stop words list is already there. No need to create. If you want to create your own list also, you can do that. Okay. There is a class called as Porter Stemmer. I have done stemming here, not lemmatization. I'm actually doing that whole cleanup process in a loop. Right. So I have taken corpus, a list, empty list, and I'm using regular expressions here. I'll show regular expressions also Monday. Right. So regular expressions substitute wherever I find non-alphabets, right? The A to Z and A to Z, capitals and smalls. If I convert everything to lowercase, right, then no need to put this A to Z. This cap actually says that not alphabets, replace them with space. Okay, any numbers, any other characters, right, replace them with space in reviews of I, right. First review, it will check whether there are any non-alphabets, replace them with space, like that. No, every no second review, third review, like that, right. It replaced it, and then lowercase. Maybe I should have done this lowercase thing up, and then I would have removed this and did only lowercase, and then splitting. When I call split on a string object, it will take the spaces as the delimiter and split the data. This is tokenization. Okay, there are classes to do tokenization. You can just do split also if you want space as the delimiter, right? So this is tokenization. Till here we cleaned it a little bit, and then here we tokenized. Now we are doing stemming, right? How do you do stemming? In a review, there are many words, right? So per word in review, that will actually loop through, right, all the words. If not word, right, this is the in a review the first word came in, and I am checking that first word is present in the stop words or not, right. I created a set of stop words for English, right. In this NLTK stop words there are other language support also, right? NLTK stop words. So I have taken the English stop words, and if the word is not present in it, I'm doing stemming on it and creating a list of it. This is list comprehension, right? This for loop is what is the key thing. Inside this for loop there is another for loop. For every review there will be multiple words. I am taking individual word and checking whether it is not present in stop words, then only I am taking it and applying stemming and putting into list. This is the new list. Okay, and then I joined the review with a blank blank string that actually created this, and then this whole thing is being appended to this corpus. Okay, the first word, first sentence changed like this, appended to corpus. Second change like this, appended to corpus. Third change like this, appended to corpus. This is the whole list of sentences we have got from the um, restaurant reviews data. This part is clear?
One question, sir. So whatever the output you are showing, it is after applying the stop words.
Yes, sir.
Okay. So in that case, for example, in the third row in the output, third row in the output, TASTI is there. It's not a proper English word.
Yes.
So you think the stop words set has this word? That's what it means?
No. If you look at the third row, right, in the review, see this not tasty and the texture was just nasty, right? This is the word, actual word. After
Okay.
processing, right, it became like tasty, texture, nasty. See, my doubt was correct. See, it actually removed not also. The processing, right, in the stop words list, there is a not word also. Let me try to execute this and show you the stop words. That's a good question. The point you got it, right? Your question got answered, right?
Yeah, so why it got changed to TSTA? That's what is the probably the root word it identified as.
Yeah, the stemmer identified the root word for tasty as TASTI. So
Okay.
there is a danger. There is a danger of mapping two distinct words to a single word, because it is grammatically or in English point of view it is not right. The stemmer is not doing it right because it has got some rules and it is applying those rules while chopping off or trying to create the root, find out the root word, right?
Sure.
So it is not exactly chopping off, right? It is
Yeah,
sometimes appending also,
they're
or
doing
maybe.
some, yeah, doing some other activity also, but I am, yeah, in a layman's terminology I'm talking. When you look at the output, right, you will know that it is doing something else also. If you look at tasty, the spelling is tasty, and it actually took out y and kept I there. That's a rule actually. It's a rules only. Stammer is based on rules only. There is no dictionary. There is no mapping. But lemmatization has got mapping. It will do some rules as well as mapping, both. Lemmatization is more intelligent, but it takes more time. Generally, if you do stemming, right, that works for most of the problems. But if you see this here, there was a problem that occurred with the stop words. Okay, if you see, let me try to run this code. No, data isn't right. So there are 1,000 records. I've taken this from Kaggle, I think. So I am downloading these. I'll still show stop words. And there are stop words. I think stop words are there. No need to download. See this? These are all the stop words already predefined in NLTK. I think there is not also somewhere. See this?
Not is there, sir.
Then how did you see this? Not
Yeah.
is there.
Is there?
Yeah.
Yeah.
Right. So we should not have not in there because we should remove this. Remove it from. So let me try to create new stop words. Because if not is removed, right, the negative and positive, whatever that essence will be lost in the data. So when you are representing your text or you are actually pre-processing your text, you need to make sure that the essence is kept intact. What is the essence here? The negativity and positivity. Not is negativity, right? Good, not having not is positive. Most of the cases, I cannot say that not is negativity all the time, right? Not bad, right? Not bad is actually good, right? So then dot. Can I remove a string from list? Totally gone. Oh, totally gone. So how to remove a string from list in Python? Find out the index and then remove it, right? So how to find out
No,
index?
not required, sir. I think delete or something. Delete or something is there.
So remove is there, so remove.
Remove is there.
Remove we can use it.
Remove pop.
Hmm.
Pop is it. String object can't be stored as integer. Okay. I think we need to. Yeah, it is actually. Is that a list? That's what we need to see first. It is a list, right? It's a list. Remove should work.
So remove will work, sir, I think.
Sir, you are doing the reassignment. You should not do the reassignment, sir.
Okay.
Yes, sir. Reassignment is not required.
That's
Hmm.
so maybe I should run the code again. Yeah, reassignment is the problem. Still not work. Okay.
The old variable was there. Just print the stopwords. Yeah.
I think I should take this into a variable and then do it. Okay.
My stopwords dot words dot English. Words dot English should be removed.
Now,
Yeah, it got removed.
yes, good. Right now we will actually use this. So that's the care we should be taking. Right. So now I run this code. See, knots are there now. Right. Now it's going to be. It is going to work better now. The model is going to work better. So now I have the corpus ready. Right, now I have the corpus ready. Right, all the data. Now I'll use count vectorizer, which will actually represent this kind of thing. I am going to create a numerical representation, right, of input variables. So that is going to be created by count vectorizer. Okay. So scikit-learn feature extraction text has got count vectorizer. I said max features 20. I'll take the best 20 features only. Okay. So there's going to be 20 columns only. If I take this out, there may be as default number of features it's actually take. Max features none. It will take all the features. Okay. So let me take out this and try to maybe keep it that way. So now I created an object of count vectorizer and then saying fit transform, right? Fit transform of the corpus, right? It is actually creating this x. This x is going to be a array, numpy array. I'll show you in a moment. Y value is going to be the last column in the data set, right? Reduce data set last column. So this part right? Vocabulary underscore will give you which one now is actually considered out of all these 20. See, not is considered as the 11th feature. So most prominent features it will consider. Okay, max features. And now I am looking at the x. See that it's like this. This is a numpy array we have got. If I take out this, our data became like a numerical representation, right? I'm looking at 5 rows, all columns, right? So if I take out this max features, big max, right? There are, I think max number we can see maybe around 1500 distinct words it found. And there are many columns and many rows. And now I am doing train test split of this data. Actually, I should have done the train test split beginning, but no, for my convenience, I actually not did that. Okay, a text itself you should actually split it first, and then do the numerical representation, bag of words thing. Okay, but here I am doing it, right? Did it. So I am using Bernoulli naive Bayes algorithm. What is naive Bayes algorithm? How it works? We'll see that. Okay. So Bernoulli naive Bayes, there are three variants: Bernoulli, multinomial, and then Gaussian naive Bayes. So three variants are there. Why three variants? Also, I'll explain. Okay. So scikit-learn naive Bayes and took the x and y. You can take logistic regression. You can take random forest. You can take SVM. Any algorithm you can take. I took naive Bayes because of one reason. Okay, I'll explain that also tomorrow. Once we know the algorithm, right, I'll explain. So I am fitting the model. I'm trying to predict. I'm trying to calculate confusion matrix. So the model is actually kind of not that good here. See this, um, there are false positives and false negatives, right? So let me take 20 features only and see how what happens. Yeah, it improved a little bit. No, no, not that much. Okay, so this is how you actually represent your data, that bag of words data. And when a new record comes in, when a new record comes in, when a new review comes in, what should we do? When a new review comes in, what should we do in this code?
It should be uploaded with all the steps.
All the steps, right? First, we need to actually create this kind of tokenizer, right? Tokenization, tokenized text of that review, right? Then what we should do? Should we do this count vectorization of that?
I think not required, sir. We can transform directly.
But we can transform, but count vectorizer is the one which will actually transform it to numbers. So the question here is, should we be using this CV dot transform, or should we be taking a new count vectorizer and doing fit transform on the new review? Did you get the question? Shall I take a new count vectorizer object and then applying fit transform on the new review, or do I need to save this CV object somewhere and do the CV.fit transform?
We need to do the count vectorizer in order to get the which word occurred in the new record, how many times and all, right?
Yes, Sandy. To create this record, we need to do count vectorizer. My question is, should I use this count vectorizer or a brand new count vectorizer?
When you say brand new, using the fit transform?
Maybe, first question, maybe, should I use fit transform or transform on the new record?
Transform only.
Transform only, right?
Yeah.
So what will happen if I do transform only? What will happen if I do transform only? That's a good, very important question. You may, the question may sound very funny, but that's a very important question. When I do transform using this particular object, what will happen?
Maybe it will not give that number to the new word.
New word in the sense?
For example, if you are added new text, right?
In that, if you don't have these words,
yeah.
in the new sentence, if you don't have these words, what will happen to the row?
Yeah, it will become zeros. We'll get zeros.
All zeros. It will become all zeros, right?
Yeah.
Should we be doing that way, or should we be doing a fit transform on the new text? Because it is becoming zero.
Yeah, we need to do the fit also, so that that also comes into picture.
No, sir, no. Because the algorithm we trained on using these features, right? If these features appear in the production data, right, then only the model will be able to predict it. So the data you trained on and the data you are testing on and the production should be similar. Rather, the machine learning, the algorithm will not work perfect. Got it? Got the point? The point I am trying to make is you should use transform only on the test set and production. And when you do transform, it will actually take it will look at these features. These words are present in the new sentence or not. If it is there, then it is going to create counts. If it is not there, it is going to take all zeros, and the model, the prediction is not going to work well. So the important thing we need to remember is the sampling should be right. The corpus should get created properly. If the sampling is not right, the model will not work well. Got it?
Yes, sir.
Why model is not getting created, not working well? Because the features are not being captured properly. The ultimate numerical representation, when the features in the sample are not right, the numerical representation is not right. Because of numerical representation not right, the algorithm is not working. Your data scientist's capability of choosing sample was the failure where the model is not working. Right? So sampling is very important. Got it?
Yes, sir.
So that is that is naive based algorithm and a bag of words model. Right. That's a bag of words model and naive based algorithm, right? So I in production. So I actually intentionally did the split after doing the processing. Okay, to not to create everything comfortable. It's a kind of spoon feeding, right? So you guys have to do that. You take the data set, first split it, and then create the bag of words representation, train the model on the test set, right? On the set again you have count vectorizer, and then test it. So you need to create that model. That's an exercise. Got it? You
One
got
question, for a new record, we need to do the count vectorizer, right?
yeah.
Yeah, sure.
So we should use this one only, this object only. If you are training the model on one machine, test it on other machine, or trying to do production on other machine, right? You need to serialize this and the model also. The algorithm you need to serialize. There is the algorithm,
Sure.
this one, right? And then the count vector is also you need to serialize. If you did some standardization, you need to serialize the standardizer also. You need to take these three objects, serialize the objects there and put it there, and test it. Got it? Got it, right?
For a new record, in your current code, did you take any code there below for any new records? Sir?
No. If you actually split the data into train test upfront, right, you will get new records only. Got it? I did train test split after conversion, right? If you do train test split at the beginning itself, you will get new records only, right, in the test set. Got it?
No, that's not what I'm asking. When a new record, after the model is ready, when new record comes, whether the outcome is like 1 or 0, to finding that did the current code example have that?
No.
That's okay. That's fine. Sir.
You can actually do experimentation on this.
Yeah, sure.
And we have Amazon reviews. There is a big data set, and we'll do. So this is a basic way of creating a text classification model. There are frameworks, there are libraries like Flare, right? So I'll try to write the code. I am actually looking into them. Right? This uses PyTorch. PyTorch is one of the deep learning frameworks, right? Using this framework also, you can write a classification model. There will be a simple text classification. So zero shot learning and all that we'll learn. These all things will come in. Okay, these frameworks you can actually play with, right? So I'll try to do whatever maximum I can, right? So this is the simple example of NLP. We will cover this naive Bayes algorithm tomorrow. Okay, naive Bayes algorithm will take some time to explain because it's a lab probability and all that. Right. This let me try to. Today's class was small.